Great. Well, welcome everyone. Good morning. I guess it's still morning there. It's very early for me here in Toronto, 5 a.m., but I'm excited to be with you all for this new cloud series we're kicking off today. So welcome to the series. It's focused on infrastructure and deployment models. It's available to scientists for managing data pipelines. We're going to cover public cloud providers, particularly today. We'll also in future sessions cover public schedulers and some of the latest open source cloud native systems like Kubernetes. So some exciting stuff to come in other sessions as well. Although today we're excited to hear from Christian Yep on the AWS Batch solution and how you deploy that. I'm going to host this series. My name is Rob Lalonde. I'm Chief Commercial Officer, newly minted Chief Commercial Officer for Seqera Labs. And I'll be joined each and every webinar by our co-creator and CEO of Seqera Labs, Evan Floden. So we're going to have two guests each webinar, an infrastructure expert, in this case it's Christian, and we're going to have someone from the user community, an expert who will share advice and experience on using the technology. And in this case, it's Gisela Cabernet. So I'll introduce both of them in a minute. The intended audience is really those in the open source Nextflow community who wish to become more proficient in deploying and managing their underlying infrastructure. And this is a free and inclusive event. We're really excited to kick it off today. So on the agenda is, there's me kicking it off, and then we're going to jump right into Evan Floden, our co-founder and CEO, who is going to talk about our batch integration and setting up Nextflow and Nextflow Tower and how to use all that together. It's going to be a lot of fun. Gisela Gabernet is going to join us. She's a biologist. She was at the Autonomous University of Barcelona and did her PhD in chemoinformatics at ETH Zurich. And now she's currently the team leader for R&D in data science at the Quantitative Biology Center in Tübingen, Germany. So we're really excited to have Gisela on board for her talk. And then we're going to have Christian Yip, who's developer advocate for HPC and Batch, talk about HPC and Batch on the AWS platform, obviously. And he's based in Berlin. So we've got people scattered all over the world today that are going to deliver this talk. And then Evan's going to wrap it up a little bit with some Nextflow deployment tips, and then we will do a Q&A. So hopefully you'll stick with us. We're excited to have you here. And right out of the gate, I'm going to turn it over to Evan to kick things off.
Awesome. Thanks a lot, Rob. That's great. Let me just share with you my screen here. So yeah, really nice to kick off this series. It's something that we've been thinking about for a while, how to kind of really develop kind of community engagement, not so much specifically on the Nextflow development side, but really on the infrastructure side. It's one of the key benefits of Nextflow is simplifying that infrastructure. And really one of the reasons why I really created Seqera Labs was to focus on that part. So I'm going to first start off and begin with a very basic overview of Nextflow, but I'm going to assume that you do know a fair bit about Nextflow, or at least on the syntax side of it, and really not going to spend too much time on that. The focus will primarily be on AWS Batch today. I'm going to look at the configuration which is required for a Nextflow pipeline. Then we're going to run a quick demo and show you how that works on the batch side before passing it off, and I'll come back and finish off and talk about some of the latest advancements we have for that. So a little bit firstly on Seqera Labs. So we created the company a couple of years ago now with Paolo, the main creator of Nextflow, and myself. And as part of that, we really wanted to simplify the infrastructure. So really make the configuration of cloud and cluster much easier for end users to take. The basics of this for Nextflow, as you were probably aware, is it's both a language, so it's a scripting language, as well as a runtime for deploying on different infrastructure. The key point here is that this top part, so like how we write the pipelines, is very different and kind of completely separate from the configuration of those pipelines. And it's really become apparent that separation of these two things is really what's enabled communities like NF Core to become so successful, is the fact that you're able to have developers, bioinformaticians all around the world working on those pipelines, and then independent of the infrastructure which they ultimately deploy on, they're able to collaborate and run those pipelines anywhere. So in this box, we're really going to be focusing on the bottom part of this today, and of course on AWS Batch. So how this kind of starts off, we've also been doing some things around the Nextflow syntax. So this is around DSL2, not specifically related to the things that we'll talk about today, but something to keep in mind that this is somewhere that the language is moving. And this is where we're really seeing a lot of improvements around the efficiency of writing the code and the modularization of that code, which does have some benefits for the things that we'll show it later on. And that adoption, of course, of Nextflow has really been taking off, particularly in the last couple of years, primarily in these life science communities and the like. Okay, so when we first developed Nextflow, so coming back 2014, one of the first things we wanted to do, we were working with a scheduler. So we had a scheduling system in a cluster, and we wanted to submit those jobs to that and essentially manage that, that infrastructure, manage that submission of those jobs. So the first early on integrations, what we call executors, were really focused on this. And these were kind of the initial starting point for Nextflow. And in this model, Nextflow submits these jobs to the cluster, and the cluster then will run those jobs, and it will use, for example, a shared file system to have the data. And a kind of simplified model where Nextflow is a centralized orchestration engine in that. And then around 2016, 2017, started to see the advent of some managed services in the cloud. So early on, Nextflow had a way of creating a kind of cluster in the cloud using something called Apache Ignite. But the cloud providers, and particularly AWS, really saw that there was potential here for creating these kind of services in advance, so that you could have a managed service where you could have almost like a cluster in the cloud. And AWS Batch was the first kind of one that we integrated, and that work really was finalized around 2017. And the kind of basic model that I often show here is you can think about it, it's a little bit like submitting your jobs to a cluster. Nextflow submits the jobs, the tasks to the AWS Batch API. The AWS Batch API then spins up some virtual machines, the tasks run, you use some S3 bucket, and it kind of executes like that. And this is still a bit of a simplification of what's actually happening in the background. So it's kind of the purpose of this series is now really to focus a little bit, okay, how can we set this up? What's happening in the background, and what do we really need to be successful to run this kind of orchestration model? So expanding a little bit on what we kind of have, if we think that Nextflow is going to submit each of these tasks, what it's really doing is submitting these tasks to the Batch API. And then from the Batch API, this is really submitting it to what we call a queue. And this is the abstraction which Nextflow is using and which Batch is using. So Nextflow says, okay, run this task on this queue. And it's that queue which is mapped to a Batch compute environment. That Batch compute environment is mapped to some virtual machines. Those virtual machines are running in an ECS cluster. And from there, you get a kind of scheduling of the tasks. And what's occurring is that you can have multiple jobs onto a single virtual machine. So you can kind of have there's a packing problem which happens here, kind of packing optimization. So if I have 4 CPUs that are available and my job's taking up 1, you can imagine I can fit 4 of those tasks on there. And this becomes important later on when we think about how we're going to optimize these things and how we're going to scale out that infrastructure in the future. A quick note on how we can set this up then. So what's the kind of requirements for us to have to be able to run this? And there's kind of 3 core parts to running your Nextflow pipelines with Batch. The first is the authentication. So this is the authentication of Nextflow with AWS. And there's a couple of ways of doing this. You can have Nextflow using the AWS credentials, which are in your user environment. So this is typically the secret key and the access key. You can also include these in your Nextflow configuration file. And if you're running Nextflow itself from an EC2 instance, you can use these IAM instance roles. So Nextflow is able to take that from the environment essentially and will run the job. And that's the kind of main authentication that we're going to use. And it's the main authentication which is used for both the submission to Batch and also for the transfer of files to S3, which we'll see in a moment. The other main part, other than the authentication, is the actual configuration of the pipeline. And this is what we do with the Nextflow configuration. We have a very minimal requirements here. So we're specifying the executor that we use. AWS Batch. We're specifying the queue, and this is the same queue that I mentioned before. A container, which is required, so all of these are Dockerized executions, so everything runs in the container. We have a work directory, which is specified typically in S3 bucket, a region, and a command line tool here. Important to note, this last step is required primarily because Nextflow needs to transfer the data from S3 to the virtual machine. And to do that, it's required to use the AWS command line, at least in this basic deployment that we have here. So what happens when Nextflow submits a task to Batch? So you can imagine that you can have a pipeline that will be made up of several tasks or processes. Those individual tasks get sent to the API, and what information is kind of transferred there? Well, if you specify the amount of memory, this will get picked up there. You can specify the number of CPUs. This is kind of translated into the Batch language. Also, the container that you use is important. And also there's the actual wrapping script, which Nextflow is typically using. This is the doc command .run script that you have. What's happening inside there is Nextflow is saying, okay, these are the files which need to be transferred. They are in this location. And Nextflow is able to transfer those using the AWS command line tool for transferring from the S3 to the virtual machine. Obviously, you have the abstraction of the queue, which we mentioned before. And finally, something that's often trips people up is they think because it's a Dockerized execution that you're able to apply sort of Dockerized options such as container options. And it's actually slightly different from that you're not able to apply those options when you run with Batch itself. Okay, so I'll just go to a quick demo now and show you this in practice. So this is the Nextflow command line, and we're going to run a quick demo on kind of the minimal setup that we're required. So here you can see I have a very basic pipeline. I have a process section. So this is my steps of my pipeline. You can see I have an index step. I have a main section, which is just the main definition of that workflow. And the thing that we're really focused on here is this nextflow.config. And it's this nextflow.config, which is really where the definition and the kind of configuration of our pipeline occurs. So I've set this up with two profiles. And profiles are a very nice way to split up your configuration. And inside here, I can say, for example, I can run my pipeline with the profile local. Now this is running it locally on my machine here. So it's going to run this pipeline, and it's going to use the container that we specified, and it's going to run with Docker here. And you can see that this is a relatively quick process. This takes just a few seconds to run through this pipeline. We've got a few tasks there. Now, the great thing, and what I mentioned before, is that this is completely separate from the actual workflow logic. So once this is completed, I could then go run the exact same pipeline now with AWS Batch using this profile here. And when I launch this now, we can see that what we've done is specified some different parameters. So in this case, our reads, our input data, is already in S3. We need to specify that the executor itself is AWS Batch. Again, we can use the same container as we had before, but the key abstractions here are the use of the queue. And this is where Nextflow will submit the jobs to that queue, and we'll see exactly what that looks like in the console, as well as the settings that we have for the region that's required and the command line tool. So while that spins up, I'll switch back to the console and give you a quick tour of what happens from there. Kind of overview of that spot. So this is the AWS console that we have here, and this is the batch console that we're greeted with. As part of this, we have a set series of queues. You can see that I've been submitting to this queue here. This queue, this job queue, is linked to a compute environment. So you can see that there is a couple of jobs that are in the runnable state here. This is the state which they kind of first enter, and from there, they're basically making a request to run the job. This queue is linked to a compute environment. So remember, queue maps to a compute environment, and those compute environments in turn map to an ECS cluster. So I can go down and find the queue that I'm running this jobs on. And you can see that this will link to an ECS cluster. So I can jump into here if I really want to go into the specifics of that, and I would be able to see instances which, when they're ready, will be spun up here. So it's kind of in a kind of very transparent manner, but we're abstracting away and we're removing a lot of complexity with having to manage that in its kind of basic form. Okay, just share back my screen here. So going back to the overview here that we had before, there's a couple of other options that we have for running this in terms of the config. So I just showed you a very basic deployment where we run all of those tasks that we submitted into batch, spun up some VMs, and all of the tasks were completed, and from then the virtual machines shut down. Now, it can be also in a situation where you maybe want to split that execution. Maybe I want some of the execution, some of the tasks to run on my local HCP, so in this case Slurm, and some of the tasks I want to run in the cloud, like an AWS Batch. And you can use this approach because Nextflow is task oriented, so every task can have a different executor. We're able to split this out and have particular tasks running using a very simple config like this. Other advanced options that we can use in terms of the batch configuration. So we can use volume mounts in the Nextflow configuration. This is if you want to mount specific paths. We have custom job definitions. So by default, Nextflow has a default job definition, but if, for example, you have to run in particular high security environments where the system admins want to provide a particular job definition, provide some limitations around how that job runs, you can use those as well as using custom AMI images there. The one thing to note there is that you should include the Nextflow command line tool. So that's the first part of kind of very, very quick overview of Nextflow and how it works with Batch. I'll pass it back over to Rob, and I'll see you shortly with the follow-up.
Thanks, Evan. That was great. We'll turn things over to Gisela now, who's going to tell us a bit about NF Core on AWS and some of the cool work that they've been doing at Cubic over at University of Tübingen. So Gisela, when you're ready, we'll get you to share and come on, and hopefully you can turn on your video and we can see you. There you are. Excellent. Welcome.
Yes. Thank you, Rob, for the kind introduction. And yeah, I'm going to talk today about, let me share my screen first. So I'm going to talk today about how to run NF Core pipelines on AWS Batch, or in other words, how to get real-sized automated Nextflow pipeline tests on AWS. For the ones of you that don't know about it yet, NF Core is an open source community that develops and maintains a set of high quality Nextflow pipelines, mostly for bioinformatics analysis. And these pipelines follow a set of guidelines, such as stable releases, extensive documentations, or continuous integration tests on using GitHub Actions. And the pipelines also are executed in a containerized manner. So all the dependencies are managed with containers, which ensures the reproducibility of the analysis results. And because the pipelines are written in Nextflow, as Evan was mentioning before, and Nextflow has executor abstractions, so we can run them on different cluster with different cluster schedulers such as LARM, PBS, Kubernetes clusters, or they are also portable to AWS Cloud, Google Cloud, different cloud infrastructures. So far there are 27 released pipelines as part of the NF Core open source community and 17 under development. You can check all of the available pipelines for analysis on the NF Core website. So why did we want to implement AWS batch tests for all of our NF Core pipelines? First of all, to test that the pipelines are really portable to AWS Batch, to make sure of this, but also because we wanted to test the pipelines with full size data. Our continuous integration tests otherwise run with small size data for time reasons and for the availability of virtual machines for free for CI tests. Another reason though is that we can But by running this test with full-size data, we can check that the results are stable between different pipeline releases, and that also allows us to, in the end, display the results on the NFCO website to showcase what the NFCO pipelines can produce. So how are those automated AWS batch tests set up? To trigger the AWS tests, we make use of GitHub Actions workflows. And these GitHub Actions workflows can be triggered on different events on GitHub. For example, a certain commit to a branch or on pipeline releases. And as part of this GitHub Actions workflows, the pipeline runs are submitted to AWS Batch with the AWS client. During the run on AWS Batch, we are able to also monitor the pipeline runs with Nextflow Tower. And finally, the results of the pipelines are also transferred to an S3 bucket, and from them we can retrieve them and display the results on our website. So moving to the AWS infrastructure, we have to set up, first of all the AWS infrastructure to be able to run those tests. And we did that by using a set of CloudFormation templates that are made available by AWS directly and can be found on the link below. And these CloudFormation templates already take care of building all the AWS infrastructure that is needed for those tests, such as the batch queues, the compute environments, Nextflow container that is needed to run the head job, also the IAM roles and IAM permissions that are needed to interact with all of the AWS services. So once the workflow is triggered from the GitHub Actions workflow, the Nextflow pipeline run is submitted to AWS Batch, and the Nextflow head job is started on an on-demand instance. And this head job uses the Nextflow container that is previously created by the CloudFormation template, and it can be directly pulled from the Amazon Elastic Container Registry. This Nextflow head job then can submit the different task jobs to AWS Batch as well, and the jobs run on their own task containers. And then the Nextflow task jobs can run also on spot instances to save some money for those jobs. Of course, the instances are transferring data during all the runs to Amazon S3. So as I mentioned before, we can monitor the pipeline tests with Nextflow Tower. Here, for example, yesterday, a pipeline run for the NFCO MAC pipeline for metagenomic assembly was running yesterday. And we can keep track of all of the AWS tests running. And finally, when the pipeline results are staged to AWS S3 buckets, we can display them on our website. Here, for example, the results for the NFCO viral recon pipeline that was developed by different collaborators and NFCore for genome assembly and variant calling of viral genomes in response to the COVID-19 pandemics. So basically on the website, one can browse through the results of the pipeline, QC tests, and basically all of the pipeline results to have a look of what to expect for each of the NFCO pipelines. So since we set up the AWS Batch automated test last March last year, there has been a steady use of the AWS Batch by these tests, and we have had steady costs. In November and December, we also ran some manual tests on bigger data sets, so that's why our cost for AWS Batch increased. And of course, we are grateful to AWS for the grants, for a grant that supports these tests, and without these funds, we would not be able, of course, to maintain them ourselves. So I'd like to, setting up these tests was work of several people in NFCore, and I'd like to thank the main contributors, Friederike Hansen and Matthias Hötenhuber, Alexander Pelzer, Phil Ewells, and James Seward, who joined us in the last hackathon from AWS. And if you're interested in NFCore and our community, please join us. The next hackathon is going to be the 22nd to 24th of March this year, and you can find more information about it on our website. So that would be it from my talk, and I'll be happy to take some questions.
Great, thanks, Gisela. I don't see any questions up yet in the Q&A, but I'm sure we'll get a bunch at the end. I've just posted to ask people to share those. So please do share your questions as you go. And if you could just stop sharing, Christian will take over the screen, Gisela, and jump into his presentation. So Christian, as I mentioned earlier, is the developer advocate for HPC and Batch with AWS out of Berlin.
Yeah, so I'm afraid I need to restart my Shine to share my Zoom to share my screen. Actually, we didn't test it before, so bummer.
Oh.
I updated to Big Sur, so I guess that's a problem. So can you, maybe there's a question in the chat, so maybe if you answer this one,
Yeah, we'll
be
do that, and we'll talk amongst ourselves for a minute, and you go ahead.
Yeah, that's a good question in the chat there. So the question before was around the S3 buckets and using that for a work directory. So there's a couple of ways and a couple of things that are important with regards to this. So when Nextflow is launching, when I showed you locally before, it will actually stage the files, any files that are local, to the S3 bucket first. And this is what's called, creates a staging folder inside that bucket. And from there, any files which are then used downstream from that in the actual task will be used from that staging directory. So there's a kind of automatic transfer from your local to the storage. And it would be the same thing as if you had like a hybrid deployment where a downstream task was using something from something in S3, Nextflow would stage that back from S3 to the local machine or to the work directory where that was required. Now, of course, that comes with some some concerns or some things that you need to think about. So you don't necessarily want to be transferring huge amounts of files from local into S3. It's going to be potentially expensive. It's also going to slow down your pipeline a lot if you're doing that. So there's a kind of shift to a certain extent, where you're able to, let's say, we want to kind of automate that process and kind of think about where you put your data to begin with. So can that data be put in S3 first? Can you automatically post it there? Can you kind of use some of the policies around it for doing so? Okay.
Thanks, Evan. There's another question here about any plans for AWS cost estimation upon pipeline creation. That's a great question, and I think we've got a great answer. Go ahead, Evan.
Yeah, there's some work ongoing around the cost estimation. So it's a bit difficult to do it a priori, like in the sense that if I don't know how many tasks you're going to run of that pipeline, it's going to be difficult to know exactly, let's say, it's exactly what the cost will be. However, we can do that already at the task level. So we already can use some very basic machine learning to kind of predict and create a config. The first thing that we're doing in this regard is to actually use a cost explorer so that you can tag these resources that are used. So when you're creating these queues or when the job is created, they can be tagged with a specific tag. The next thing is really developing that and doing that on the fly for the task level. So as a task comes in, okay, this is going to use these resources and then going to be able to do it. I'm just going to bring up Christian's slides here for him, and then we can switch back over to him.
Yeah, sorry about that. My laptop was updated and there's some security foo going on. So sorry for that.
No worries.
And maybe also as a note on the cost estimation, it's good that we have tools like Nextflow and such to like predict with the experience they have how much a certain run will cost, because that's something that it's hard for us to estimate, right? So you need to know how much compute you need, how much CPU ticks actually you need. So that's something that is more suited towards those workflow managers.
Okay, great. I'm just going to have to share my whole screen here, but hopefully you'll be able to see what's going on here. Okay, all good.
And I want to switch the screen.
Okay, is it on the wrong one?
Yeah.
Sorry about that. Let's try again. say, try this one. Okay, I think we're there now.
Yep.
Cool. All right. Yeah. Sorry for the hiccup. I'm Christian. I'm developer advocate, as Rob and Evan already alluded to, for HPC and Batch at AWS. And I'm going to talk about AWS, a brief introduction. So if you click, maybe I say click and then you just advance. And yeah, this presentation is a short one, so I gloss over a couple of things, but I just want to give you a brief introduction here. So what is AWS Batch? We created AWS Batch in 2017 to create a simple batch execution, and it evolved since then, right? So you need two components to make this work. And if you can click to advance the slide. First, you need, of course, a job scheduler. So you need to take jobs from Nextflow or from other clients and make sure that you deal with the life science of those jobs. And second, you need something to execute the jobs on. So you need to have an infrastructure orchestrator that manages the life cycle of the compute resources and S3 buckets you need for this to work. So if you click, yeah. And that's, of course, only the two things you need to do, but they are they are complex. There are edge cases that you need to catch. So that's kind of a very complex task to create such a workflow or workflow manager in the cloud. And in addition, we also thought about more things here, right? We have it fully managed so that you don't pay for the actual queues or compute environments unless you actually spin up instances for this. So if you create an AWS Batch environment, you won't be charged for the queue or for the service itself. You're only charged if you spin up compute instances. So it's fully managed, which makes it super easy and useful for the Nextflow community or for the genomics community as a whole, because you don't need to worry about costs if you don't submit something to the system. The other part, of course, is that it's integrated with a lot of AWS services. I mean, Evan talked already about S3, so that you can use S3 to pull and push data back and forth. And S3, since it's super integrated to all of our services, it's a very fast way of exchanging data. We had this in the Q&A already, like how fast it's going to be compared to a shared file system. It's plenty fast, and it's also nicely scalable, right? So with S3, you have an object store that is scalable across the world, and that's kind of a nice feature of this and makes it very distinctly useful. But also services like CloudWatch, where you have logging and metrics you can get from the batch execution runs. Also, it's optimizing your resource provisioning. So it's not only spinning up instances when you need them, wind them down when you don't need them anymore. It's also looking for the jobs in the queue and look for the right sized instances for the job. So if you have a bunch of jobs in the queue, you might want to take a bigger instance to run those jobs in bulk, and this makes you more optimized for resource provisioning as well. And lastly, we also make it cost efficient, not only by choosing the right instance and the instance size, but also by offering multiple different ways of purchasing the compute nodes. We have on demand, and if you click, we also have EC2 Spot. EC2 is the capacity that is not used currently in EC2, proper EC2 on-demand instances. And you can save up to 90% of the on-demand price if you use AWS eSpot. It's the capacity that we provision for the peak demand of our users, right? And the peak demand is only used at peak times, and the rest of the day we have idle capacity that we hand out with EC2 Spot. But it's also just the amount of different instance options and instance types we have. There are 300 plus instance options now. That we also have instances, of course, that are maybe popular at a certain time of day, and the rest of the day they are not popular. So it's also due to this instance availability and breadth and depth of instances that we are able to provide this EC2 Spot instances. And I said 90% off on demand is when you tune all the knobs and you choose the right instances. But in general, we see an average of 70, 75, something like this in this region as an average discount that you can get for on-demand prices. And I think that's in line with what the Nextflow customers and Evan would also say. So And Spot you can use for not only for cost savings, but also to use more of compute with the actual budget that you have in your bucket, right? So if you save 70%, you can spin up much more instances. And this with faster results, because you have more compute, you can accelerate your innovations. Can you give it a click? And we already saw an overview by Evan and by Giselle about AWS Batch. This is our typical AWS Batch job architecture diagram. So if you click, this is supposed to be an image transformation service. So imagine that a customer sends images into an S3 bucket. This S3 bucket then triggers a job to a queue. I put the Nextflow logo here because in essence, what Nextflow is doing is also doing this triggering of jobs, right? So you submit or you create a job configuration and a job workflow for Nextflow. You fire up Nextflow. Nextflow will submit jobs out of the task that needs to be executed. And when jobs are in the queue, the scheduler will recognize that jobs are to be computed, and it will inspect the compute environment. If you advance once more, it will inspect the compute environment if the rest, if the compute instances and the sizes and the availability for compute is already in the right size and the right shape to run those jobs. It will scale up. And once they are scaled up, then the compute jobs will be flowing from the queue to the batch compute environment. And once they are finished, those jobs, of course, go back to S3 bucket, and Nextflow can trigger more jobs eventually. And I just stole this from Gisella's slides just to make explain this a little bit more. As we saw, you can use AWS Batch to run a task, right? And what we see here is what we call batch squared, or I think Evan and Paolo, you have a slightly different name. Was it? I think it was not batch squared, right? But in essence, what we are doing is we are submitting a task that is this Nextflow head job, yeah, that's running in an on-demand instance to supervise and do oversight over a series of tasks that are maybe a workflow that you want to run. So you submit a Nextflow head job that runs on an on-demand instance, a rather small one, and you from this instance you submit more AWS Batch jobs to Spot instances or other compute environments that are executed. And by doing so, you can close the lid of your laptop, because normally Nextflow needs to stay up until the complete workload is finished. And with this batch squared architecture, you make sure that you submit your Nextflow head job. This head job will submit more jobs into other queues, and you don't need to late and wait for the Nextflow job to finish. You can just submit it and forget about it until the next day you come to work. And we have a genomics workflow, a workshop there, Nextflow workshop, that you can use to play around with this idea and experience what I mean by batch squared. So this will go through this architecture a little bit more in depth. AWS Batch is, due to this reason that it's a simple batch execution environment, it's a natural fit for workflow managers like Nextflow, but also like this native workflow managers like step functions. We have an Airflow service now, and it also can trigger from S3 and so on. But it's also very much used by a lot of third-party open source tools like Nextflow, like the open source Airflow, Metaflow, and so on. So a bunch of other open source tools are using AWS Batch. Okay, can you? Yeah, and this is just a slide that shows a bunch of customers that we have that are using AWS Batch. And a lot of those, of course, are genomics and bioinformatic customers. And we see here from Gisela, it's also a big customer. And I think if you advance one more, I think that's about it. Yeah, so that's my very quick overview of AWS Batch. And if you have questions, there's a link, and also happy to take questions. And you can reach out through Evan or Rob if you like as well. Thanks. And thanks, Evan, for doing the slide DJ.
No problems.
Thanks, Christian. That was great. Appreciate it. So now we're into the question and answers. I do see one question that's just come in from Frederica Henson. Great webinar and talks by all for the hybrid execution Evan mentioned in the first part. Is or will this be possible also when setting up everything using Tower Forge? So Evan or Paulo, do you want to take that one?
Yeah, that leads in very nicely to the next section that we're going to do and really talk about the kind of solution that we've built out from there. So I'll share with you my screen again, and we can jump onto that. I think Rob, you'll have to reclaim the host again. Sorry, there we go.
Go ahead.
Okay. So the kind of final section that I want to talk about is really related to that question is how can we make this deployment very seamless? So we, as I say, came out with this solution around 4 years ago now, and there were some really common problems that people had. There's a lot of infrastructure which needs to be set up on the AWS side of it, and we, and many of the early users went through this process in a very, very manual way. So the first thing is to really consider what has to be set up here. So there's a fairly extensive series of steps for setting up the batch infrastructure and then for making it work with Nextflow. Here's just a kind of a list of those things. And what we saw early on was we tried to we got a lot of feedback from this from a lot of users. So the idea that there is a lot of, as I say, that there's 14 services or resources. I haven't actually counted them, but I take the word here. This is the situation, and this is obviously a very kind of difficult thing for people to set up. I mean, in saying so, you only want to set it up once, but still, if there's any kind of barriers and friction here, we want to really make that easier and see if we can do better. So we started off with the documentation, and the documentation is pretty extensive here, but it can be sometimes a little bit difficult to document stuff, not on the Nextflow side, really on the infrastructure side and providing step-by-steps for that. There was a bunch of really great guides that people wrote about, the step-by-step for doing so. I think some of them are probably on the webinar today. And these were kind of really useful for creating step-by-step guides for people. There is, of course, CloudFormation templates, and AWS brought out a blueprint, I think, last year, which was definitely useful for some folks. We wanted to really make that process even more simple and really eliminate the kind of need for having these kind of things. And this is really one of the main applications and one of the main functionalities that we wanted to release and we brought into Nextflow Tower about midway through last year. So Nextflow Tower is the management portal for your Nextflow pipelines. Today, I'm really just going to focus primarily on the Tower Forge feature, which is really what enables you to deploy this resources and deploy the AWS infrastructure on the fly. So why do we want to use Forge? So there's a couple of advantages here that we're able to do and automate this. How it works on the back end is it's using the AWS SDK. So we're using the APIs, the native AWS APIs to build those resources. So you don't need to use a custom AMI for setting this up. You don't have to use CloudFormation templates, which are not everyone's cup of tea, I guess you could say. You can also optionally use the GUI for doing so, and I'll show you exactly how we do that. We're also able to think about some of the more advanced setup options here. So we can now standardize that process for creating all of those resources. And we're able to add in features such as the use of shared file systems, such as the use of GPUs here, and still provide that full customization though that you're able to do when you set up your batch environment. So it's kind of happening in a very transparent manner, but simplifying it and streamlining the process overall. I should say this is really all available on tower.nf, which is exactly what I'll show you right now. So really going over to tower.nf, if you haven't seen this before, it's the management console that we have for this. So you have the ability to monitor your pipelines, but I'm really just going to show you how to create these environments today. So we can set up with Tower Forge a compute environment. Here I would specify the environment that I want to create. I'm just going to create a new environment here. So I'd say AWS Batch, put a name in here. If I wanted to do this, say create my environment, choose a platform that I want to use. And then there's a couple of things that I'm going to set up to begin with. We need some credentials. We need a region. This is using the API, so it makes it relatively simple to set up. And we want to choose a work directory. Again, it's going to use the work directories that are, or the S3 buckets that are available to me. And I can use this forge mode, which is going to create all of the resources on the fly. There's a link here that shows you the permissions that are required. And so obviously the user with those credentials needs to have those permissions to be able to do so. Specify the number of CPUs that I want, and then I can launch the environment. So that's going to create that environment now on the fly. And it'll take about 60 seconds the first time you set this up to create all those resources in AWS. And this is really going through all of those steps that I showed you before for doing so. Once the environment's ready and available to you, you can select it, launch the pipeline from here. Again, Nextflow pipelines are all Git repos. So I'm able to select the pipeline, and it's going to launch into that resources now in a kind of transparent manner for doing so. And be able to monitor the execution. I just want to take a moment though and just have a look at some of the more advanced things that we can do as part of that as well. So I just kind of showed you the kind of basic default version of setting up those environments, but we can also think about some of the more specific stuff here. So inside these compute environments, we have quite a few options here. And the idea is that we wanted to provide all the options that you can do using the console, or when you set this up annually, but provided in a way which is a little bit simplified. So you can have the provisioning model can be on demand or spot. And this means that it enables you to have those CPUs which are either kind of always on or just on and spot. We have the ability to have auto scaling, and this EBS auto scaling is the size of the disk on each of those virtual machines that spin up. So when Batch submits to EC2, spins up a virtual machine, that disk size will be able to change and will be able to expand. Particularly if you've large genomic data sets, you want to be able to enable that. We've recently added in this ability to use Fusion mounts, and this mounts the S3 bucket like it's a local file system. And this has the advantage of not having to use the AWS command line tool anymore. If you remember, a lot of the models we've been showing you have had the data being transferred from S3, and that's typically happening with the command line interface tool. So as part of this, it kind of removes that requirement and gets some performance and stability enhancements, particularly for pipelines that are very data intensive. Have the ability to have these GPUs inside EC2 instances, as well as the ability to use FSX for Lustre, so a shared file system which you can connect into your instances. We also have all the options that are available for doing so. So you can choose the instance types. This is the machines that will be making up, that will actually be making up the queues that you have. Allocation strategy. This is the kind of typically left as optimal. And this means that you are delegating to Batch to choose which instances are brought up based on what's in the queue. And this is a kind of typically will be left alone, but you have different options for doing so, and you can read about those. You can choose which VPC you are placing these resources in, some subnets. You can also use in here a particular key pair. This is a way that you can SSH into those machines if afterwards or while the task is running, if you wish to find out more. And then you have the ability to change the number of CPUs on the head job. This is the way where this is the job, the location when the Nextflow job runs, and you have the compute job as well. This is where the actual compute task will run. So you kind of have a separation of those two things. And the diagrams before, there was you saw them that you're typically placing the head job on an on-demand instance, whereas you're placing the queue and the compute queue should be on spot instances to save you some resources. So that's a kind of a quick overview of what we've kind of got so far. I'll just switch back to the slides that we have that I have over here. So kind of discuss a little bit of the performance advantages. So why do you want to use this? So obviously there's the ease of use. There's a kind of standardized way that you can do it. But of course there's performance advantages in doing so, having this EBS auto scaling, this FSX for Lustre, and these Fusion mounts. And this is something that we're going to be spending a lot more of our time doing, is really making this system more performant for people running at scale, particularly in production. Other things that we're adding in, and this is just a kind of, I'm going to give a small sort of sneak preview of the things that's kind of coming in the roadmap here, is we have the ability to have these pipelines which are pre-built, and these can then be, for example, end users who just need to select these pipelines and run. The ability to have these teams have those resources shared. So one person can set up the batch compute environment, and then all of the users can use that same compute environment without having to redo that and set that up themselves every time. As well as this whole thing is really driven by an API. So you can create batch compute environments from the API. You can create quick command line tools and quick command line commands to create those resources and to really fully customize that if you want to do all of this in a very kind of reproducible way. And of course, the whole thing can be deployed on AWS. So it can be deployed typically with a Kubernetes cluster. So this is into EKS that we're deploying Tower itself. Since I have 2 minutes, I just wanted to share with you as well and kind of give a little preview of what we have coming out in terms of a live demo of Tower. So the functionality that I spoke about before is now becoming quite advanced. So inside the application, we have the idea of organizations, and these organizations can have workspaces, members, teams. We're trying to build the whole kind of layer around Nextflow. This means that inside workspaces, I can have pipelines where people can run, and if they're in the same team as me, I'm able to view these pipelines. But I can also build in functionality around Launchpad. So this is some work taken from the NF Core community developing this JSON schema together. And as part of this, we're able to render the pipeline input form inside of Tower. And this will be really simplified the way that users who are not so familiar with Nextflow or are able to launch these pipelines in a much more simplified way. Obviously, as part of that, we can have participants and all sorts of great stuff which we'll be adding in here. Okay, so I think with that, I think we should be wrapping up the main section there. There's a few tips and tricks that we wanted to kind of mention to people who are using Batch and thinking about this. The first is that these task size should be kind of sensible. And this means that you have to think that your task, you don't want a task which is going to run for like 1 second or 10 seconds, because in this case, you're going to have to pull that container. There's going to be transfer of the data. You're going to spend much more time sort of provisioning the job, then it will run. So you have to think a little bit in advance about the kind of size of that. Likewise, the resources. So there's a kind of minimum amount of resources which is allocated to each job, which I think is one CPU and 1 gigabyte of memory. So you need to think about that, otherwise you're going to be wasting some resources. This was brought up before, but considering where the data is, we're very clear about knowing where your data is, because Nextflow is smart, and it will try and transfer the data from local to S3 and back again if you so specify it like that. So being aware of that will help you speed up your pipelines and obviously avoid unwanted costs there. Sometimes it can be useful to select specific instance types within your queues. And this is particularly relevant to what Christian was saying about the types of instances which are available on Spot are changing depending on the demand of those instances. So sometimes once you've used and defined your pipeline after a while, you're kind of moving to production, you might want to specify instances which really fit the profile of your tasks so that you're able to do that, and then sometimes not be too narrow that only those instances are available in your region. So think about that a little bit as well. Final couple of things on containers. So all of these jobs are running inside of the containers. It can be useful to host those containers in ACR, and obviously in the same region that you have them. This will avoid transferring that container potentially from the other side of the world across to each of your tasks that run, and particularly if these containers can be big, a couple of gigabytes, it's going to be a lot of wasted time. And we've even seen some people who are preloading the container inside the AMI image, so that you don't even have to do any pulling itself. There's a bunch of tricks that we were kind of working on here and kind of trying to optimize and automate that process overall as well. Okay, that's about me done. I think we're pretty good for time here. I'll pass it back over to you, Rob.
Great, thank you. And while we're doing that, let's just address that question in Q&A if you don't mind, Evan, and if Christian or you want to take that one. Do you see that? I can read it out.
For the optimal instance, great presentation, everyone. For the optimal instance selection, how does Batch select the best instance for your job from the range available? So there are two things. Like as Evan said, when you go through the Batch configuration, you can choose the instances that you want to be part of your compute environment. Let's say you say C5, C4, in various sizes. When a job is in the queue, the scheduler will just check for available vCPUs, for GPUs, for memory, and so on. So it would just look at the characteristics of the job and the characteristics of the instances available, and then pick the right amount of vCPUs, for instance. So it's not going to dig as deep as this job needs a Sky Lake, this job needs a Cascade Lake. So it won't go into that depth, but it will just look for the resource requirements for the job and task.
Great. It doesn't look like we have any other questions. So let me just move on and wrap things up. We've got about 1 minute left. So we're going to be doing this pretty much every month. We're really excited to talk about different topics each month. And you can see on the right what we're going to be covering as we go forward. This is subject to change, of course, if we come up with something new and exciting we want to talk about instead. But we'll try and keep them time zone friendly. We'll do 2 events when we're doing these, one that's Europe time friendly and one that's US time friendly, so that everyone can participate and get involved. And we'll also record these for people that missed it. So you can share the link with your friends when you receive it if they wanted to join and didn't. And then just lastly, if you want to learn more, there's some great blogs on our website about training and the workshops and the various resources, so you can get up to speed with Nextflow and Nextflow Tower. We offer services as well at Seqera. We are the Nextflow creators and the commercial organization behind Nextflow. So things like enterprise extensions and tower deployments, workshops, all those kinds of things we're able to help you with. And you can reach out to me if you have any interest in any of that. You can see my email and my Twitter handle there on the bottom left. Just give me a sec to jot that down, but you can also reach us just off our website as well. So feel free to reach out at any time. And that's all we wanted to cover today. So we really appreciate your time. And I want to thank you for attending. And if Evan, maybe you just say a quick wrap and we'll be done.
Yeah, thanks a lot for joining, everyone. Really excited. Hope you can join us for the future episodes as they come out. Take care, everyone.
You bet. Thank you, everyone. Bye-bye.
Bye.